this video, I'm going to show how to make a force sensor using a waffle weave structure. And so what this video is going to show is a little bit about, one, how to describe these structures in AutoCAD, but also some practices I've developed specifically around using weft systems that have made it easier when I'm designing woven drafts with circuitry regions within them. So the idea here is we're going to create a swatch of waffle weave, and then we're going to embed a little press button in the middle of it. Okay, so what we're going to do to start is I've just cleared off our draft, and before you got here, I selected the whole draft region, and I filled it with my waffle weave stitch. Okay, so if we were just making a waffle weave, this would be enough, except for maybe we'd want to customize some of our materials. So I'm actually going to go ahead and do that. So I want, let's say I have black in my warp. I'm going to do like a real baby pink in the weft. And I am going to make sure that every weft yarn is assigned to that baby pink. Okay, so again, if this was just going to be a plain waffle weave fabric, this is a structure that we might use. But the idea I want to do is to take a region in the middle and make it a force button, and then also to route those yarns out to the side so we could connect to them. All right, you ready for this? Okay, so the way I found it to be most useful is that I assign one weft system to my base material and another weft system to my conductive material. So to show you how I do that, I have this green material, which I'm calling my conductive material. In reality, it's kind of more of like a silvery gold. So I'm actually just going to make it kind of a silvery gold color. All right, and now I am going to assign all of my weft systems to this alternating A-B pattern. So there I go. And then I'm also going to assign them to my materials. So system A becomes associated with my base material, and system B becomes associated with my conductive material. Now, the structure that I'm showing here actually might work for force sensing, because it would mean that every other pick we're throwing a conductive shuttle. And because of the waffle weave, its structure is sort of expanded when it's not under pressure, and then it collapses under pressure. And that collapsing is what gives us a change in resistance in our conductive yarns that we can measure and call it a force button. But in actuality, I find it better to duplicate every row, right? So instead of having this structure, which is split across the two systems, what I would do instead is go ahead and design the waffle weave independently on both the systems. So I'll show you what I mean. Okay, I'm going to hide my my conductive rows and just show my base rows. Then I'm going to come in here and I'm going to select all of this region, and I'm going to fill it with my waffle weave stitch. Okay, then I'm going to do that exact same thing on the other system. Okay, so I select it all and I fill it with this stitch. Okay, so now when I look out, I've basically doubled the height. I've made this a two-pick structure instead of a single pick structure. So what that allows me is, because usually the conductive yarns are a lot thinner than the other yarns that I'm using. So this allows me to kind of almost consider that second pick as negligible in size. All right, so if I were actually going to weave this, what I'd be weaving is an entire patch of one continuous conductive yarn that goes back and forth and back and forth. And this entire patch, you could measure it, this entire patch is a force sensor. But let's say we want to make this a little more elegant and we just want our force sensor to be in the middle of the patch. Well, then we can actually just go back. Oops, this is our conductive layer. And I like working in the draft view better. We can go in and we can erase out the regions where we don't want the sensor to be. So we can do that two ways. One is that we could just erase everything on this layer. Nah, I'm going to do it this way because I want to make sure that everything lines up. I'm going to erase that out. Then I'm going to erase this out. And then I'm going to give myself some room on top and bottom. Okay, so now if I were just looking at the conductive layer, it would only be integrated in this little section. And when I add it back to both layers, you see how that structure looks quite different. And you look in visual mode, and you can see how that second pick is really only in the middle. The other helpful thing here is we can look at circuit mode. So circuit mode helps you see the paths of electricity beyond any particular structure. So it makes it look much more like a circuit schematic than anything else. And what I can actually see here is that there's these rows that don't go all the way across. And so what I can actually do is take my interlacement tool and try to expand this out. There we go. So I'm going to kind of draw on top there to get that to expand out. And if I was really weaving this, I might want this pick to come all the way out the back of my fabric. And so what I would do there is I'm going to say, okay, I'm going to work looking only at my conductive row. I'm going to take this heddle marker here and I'm going to fill it all the way out to the side. So this means that this yarn is going to run under the back of my fabric. And let's see back on the circuit view. Okay, I can do the same thing on this other side. So let's go and I'll go ahead and move it across. So now what would essentially happen is I would throw in my conductive yarn on the roughly 50th row, and then I would weave it in alternatively with the base material, and it would integrate a little patch in this region. Okay, so we can look at that in all the different modes. This one shows us in terms of the structure. We can go back to the draft, and then we can look at the whole draft together. Now, in this visual mode, it really seems stretched out because we're basically allowing space for visualizing both the yarns. But in reality, this will be a much more compressed fabric, especially if you're beating it a little bit more harshly. The other thing that we can do here, and now that we've actually defined these lead points, it might be a little bit hard, but what we can actually do is specify which direction we want that conductive to be thrown in. So if I go in here, right now I'm assuming it's going to be inserted from the left, but if I say insert from right, it will actually change. Sometimes you have to update the view. See, now it's coming in from the right, and you see it's having a bit harder time aligning. So we would have to go in and erase that and draw it out here. So it's smart like that. It kind of knows how the sort of path is going to travel based on the side that you're throwing it in on. So let me go back to this. I'm going to say nope, go back, throw it in from the left. And again, I have to do something to update the view. And there it is, back from the left. Another thing I've been known to do is sometimes, and this is still a little bit hacky in this system, but sometimes I'll actually string in a supplemental warp that's made of my conductive material. So here I've added this warp. Let's say I'm actually going to string a conductive material through this warp. I could use that to now attach onto here, right? And I could cut it in the middle and actually have my leads come out of the top and bottom. So that's another technique that I use. Um, and with that, that is my how to create a pressure sensing fabric demo. And I will hit print right now, and I'll hit print on the draft, and I will save this to our website so you can follow it whenever you please. Thanks so much.